appreciate that there is a weak interaction between quarks giving rise to beta decay. Alright, so now we have to talk about beta minus and beta plus decay in terms of the new model that I just told you guys about, the quark model, right? We have a neutron, and the neutron decays into proton. And in this process, it releases an electron and releases an anti-electron neutrino, right? So, how do you explain this entire change using the quark model? It's actually very easy. A neutron is basically down, down, up, right? So one of the quarks, up, up, down. So all you need to do to turn a neutron into a proton is change the flavor. These are called flavors. These are the different types. Change the flavor of one of the quarks from down to up. এই চেঞ্জটা করে ফেলতে পারলেই তোমার কিন্তু you have a beta decay, right? And also neutron breaks into a proton. So this has to be done by something. And it's done by a specific force, which is, as we know, a weak nuclear force. Yeah. Weak nuclear force is like W minus, is W plus, is. So in this case, W minus acts. Do you get it? So when you have a weak nuclear force acting, it causes the change of flavor from down to up. And during this process, we're not getting the creation of any new matter. Matter also. You started with 3 quarks, you have to end with 3 quarks. So that's why a processor we have the release of a lepton and an anti-lepton. Do you get it? A processor lepton and anti-lepton release. So if I say that, what's the total number of leptons released in this process?
What's the total number?
We started with 3 quarks, and we caused the release of 1 lepton. The lepton here, if you're talking about beta minus, the lepton is what? It's an electron. You can have beta minus like so if you're kind of confused. So you can act a lepton window, and we have an anti-lepton. So what is the total number of leptons produced in this process? 4 leptons.
Because sir, leptons are made of 2 types of quarks now.
Leptons are not made of any quarks. Fundamental particles are quarks and leptons.
Quarks and leptons.
Up, down, top, bottom, strange charm. These are the quarks. There's no mesons or baryons. We could consider this, but আমরা আলাদা quark হিসেবে দেখতেছি এখানে। আর with this lepton এই পুরো process lepton আছে এইটা আর এই anti-lepton আছে. Actually, the total number of leptons produced is 0. Do you get the concept of that?
Yes.
You have no matter. Why do you have no matter in terms of leptons? Because you created 1 lepton and you created 1 anti-lepton. The anti-lepton is the opposite of a lepton. It's opposite of matter. It's antimatter. So how much lepton matter did you get out of this process? Nothing. Total number of leptons released? 0. Cannot, because we lepton power to the anti-lepton. One way of explaining this would be, okay, amakase 0 as, right? I can rewrite 0 as plus 1 minus 1. So what's the total here still? 0. Do you get it? It's not like I'm creating values out of 0. But what I am doing, I'm creating equal and opposite values. If I were to sum them, put them together again, I still get a 0. This is the basic concept of creation, where you create matter out of nothing. The idea is, whenever you create matter out of nothing, you must create equal amounts of antimatter. So that if they were to be brought together again, you'd end up with no matter out again, right? So you conserve this idea of creation. So upon matter and antimatter, so the total number of leptons here is 0. Does this make sense?
Sir, how is a lepton definition?
Lepton definition. A lepton is a fundamental particle, and it does not interact with strong nuclear forces.
So boron differentiating hadrons and leptons. Hadrons are made of 3 types of quarks. It is the definition, right?
But now, what's a lepton? So the definition might come, what's a lepton or what's a quark? If you're talking about leptons and quarks, that's one level, fundamental particles.
Lepton does not
interact with strong nuclear forces.
So the question was, what's the difference between hadrons and leptons, right?
The difference between hadrons and leptons.
Yeah, so what should be the
hadrons and leptons? The question asked. আসছে আচ্ছা আসলে it's really simple. A hadron is a combination of quarks.
Three types of quarks होता है.
Hadrons না just quark combination because they can be baryons or mesons. Hadron এর নিচে you could have baryons, তিনটা quark, or you could have mesons, which is a quark anti-quark combination. But leptons, they don't combine. They have no quark combination. বুঝছো? So similarly, you can also say hadrons interact with strong nuclear forces. বুঝছো? While leptons do not. Leptons never interact with strong nuclear forces. এর জন্যই দেখো নিউক্লিয়াস থেকে এখানে বের হয়েছে তোমার electron neutrino, anti-electron neutrino, but তোমার they eject themselves out of the nucleus at high speeds. ঠিক আছে? That's because they can't get binded. ওরা আটকে থাকতেও পারে না। আর এই প্রসেসটা যে এনার্জি রিলিজ করে ওই এনার্জিটা ওরা কাইনেটিক এনার্জি হিসাবে নিয়েও বের হয়ে যায়। Do you get it?
Yeah.
So this is the concept of beta minus. So if this was beta plus, ঠিক আছে? It would basically be a mirror reflection of what's going on. The force interacting would no longer be W minus, it would be W plus. And এদিকে না গিয়ে it would go এদিকে। বুঝছো? আমি এটার মধ্যেই আঁকতেছি so that you can compare the two. So তখন গিয়ে a proton would decay into a neutron, ঠিক আছে? And in the process it would release an anti-electron. You get it? And an electron neutrino. So that would be beta plus. So ekdom simply যদি short করে বলি beta minus হইতেছে যখন neutron decays into a proton, you get an electron and an anti-electron neutrino. And beta it's done by weak nuclear W minus এটা আর beta plus হলে কি হবে? A proton decays into a neutron and in the process releases an anti-electron and an electron neutrino. And the force related to this, the weak nuclear force, is W plus. Do you get this? So this is beta plus, which is basically the reverse of beta minus. So beta minus হবে কখন? When a nucleus has too many neutrons. ঠিক আছে? Unstable though, এটা stabilize করতে গিয়ে you need more protons because neutrons are বেশি. So a nucleus has too many neutrons. Beta plus হবে কখন? When it has too many protons. And obviously you need the weak nuclear force to act there to cause a change in flavor. Either down to up or in the case of beta plus up to down. So is this clear to everyone?
Yeah.
All right. ঠিক আছে কি প্রবলেম বললা আবার বলো
স্যার কোশ্চেন গুলো করতে পারেন চ্যাপ্টার ওয়াইজ
আচ্ছা করতেছি দাঁড়াও
চ্যাপ্টার ওয়াইজ কি